Hello students, today we will discuss new topic, that is basic properties of Laplace transform. So first property is linearity. If Laplace of f1t is equal to f1s and Laplace of f2t is equal to f2s, then Laplace of a f1t plus b f2t is equal to a f1s plus b f2s, where a and b are constants. So proof: we know that Laplace of f of t is equal to integration 0 to infinite e raised to minus st f of t dt. So by definition, Laplace of a f1t plus b f2t is given by integration 0 to infinite e raised to minus st in bracket a f1t plus b f2t dt. So if we simplify this, then it will be a integration 0 to infinite e raised to minus st f1t dt plus b integration 0 to infinite e raised to minus st f2t dt. So this can be written as f1s and this can be written as f2s. So this is equal to a f1s plus b f2s. Therefore, Laplace of a f1t plus b f2t is given by a f1s plus b f2s. Now let us discuss examples related to this. First example, find the Laplace transform of 2t cube plus e raised to minus 2t plus t raised to 4 by 3. So Laplace of 2t cube plus e raised to minus 2t plus t raised to 4 by 3 is given by 2 into Laplace of t cube plus Laplace of e raised to minus 2t plus Laplace of t raised to 4 by 3. Now we know that Laplace of t raised to n is n factorial divided by s raised to n plus 1 when n is positive integer. So here n is 3, which is positive integer. Therefore Laplace of t cube will be 3 factorial divided by s raised to 3 plus 1. Same way, Laplace of e raised to minus at will be 1 divided by s plus a. So here Laplace of e raised to minus 2t will be 1 divided by s plus 2. And here Laplace of t raised to 4 by 3, here 4 by 3 is not an integer, therefore it will be gamma n plus 1 divided by s raised to n plus 1. Now here 3 factorial is 6, so 6 into 2 will be 12, 12 divided by s raised to 4 plus 1 divided by s plus 2, and here we will use this property gamma n plus 1 is equal to n gamma n. Therefore according to this property, gamma 4 by 3 plus 1 can be written as 4 by 3 into gamma 4 by 3 divided by s raised to 7 by 3. So if we simplify further, then it will be 12 divided by s raised to 4 plus 1 divided by s plus 2, here 4 by 3, and here again we will use this property gamma n plus 1 is equal to n gamma n. So according to this property, gamma 4 by 3 will be 1 by 3 into gamma 1 by 3 divided by s raised to 7 by 3. So if we simplify further, then it will be 12 divided by s raised to 4 plus 1 divided by s plus 2 plus 4 divided by 9 into gamma 1 by 3 divided by s raised to 7 by 3. So this is our final answer. Now let us discuss second example. Find the Laplace transform of 100 raised to t plus 2t raised to 10 plus sin 10t. So this can be written as Laplace of 100 raised to t plus 2 into Laplace of t raised to 10 plus Laplace of sin 10t. Now 100 raised to t can be written as e raised to log 100 raised to t. So this can be written as Laplace of e raised to t into log 100 base e plus 2 into Laplace of t raised to 10 plus Laplace of sin 10t. So this is Laplace of e raised to at. So Laplace of e raised to at can be written as 1 divided by s minus a. So by this it will be 1 divided by s minus log 100 base e. So here Laplace of t raised to 10 will be 10 factorial divided by s raised to 11, because Laplace of t raised to n is n factorial divided by s raised to n plus 1, where n is a positive integer. So it will be 2 into 10 factorial divided by s raised to 11. And Laplace of sin 80 will be a divided by s square plus a square. So here a is 10, so it will be 10 divided by s square plus 100. Now let us discuss third example. Find the Laplace transform of sin 2t into sin 3t. So here multiplying by minus 2 and dividing by minus 2, so it will be Laplace of minus 2 sin 2t sin 3t. Now here using the formula minus 2ss, so it will be c minus c. So by that formula it will be Laplace of cos phi t minus cos minus t, because here addition of angles, so 2t plus 3t is phi t, and here subtraction of angles, so it will be 2t minus 3t, so it will be minus t. Now we know that cos minus theta is cos theta, so it will be cos t. So it will be Laplace of cos phi t minus Laplace of cos t. Now Laplace of cos at is given by s divided by s square plus a square. Here a is phi, so it will be s divided by s square plus 25. Same way Laplace of cos t is given by s divided by s square plus 1, because here a is 1. So if we simplify it, then it will be s cube plus s minus s cube minus 25s divided by s square plus 25 into s square plus 1. So s cube cancel out, so it will be minus 24s divided by s square plus 25 into s square plus 1. Okay, so if we simplify it, then 24 divided by 2 will be 12. So it will be 12s divided by s square plus 25 into s square plus 1. So this is our final answer. Now let us discuss example number 4. Find the Laplace transform of sin square 3t. So here we will use half angle formula. So by that formula it will be Laplace of 1 minus cos 60 whole divided by 2. So it can be written as 1 by 2 in bracket Laplace of 1 minus Laplace of cos 60. Now Laplace of 1 is given by 1 divided by s, and Laplace of cos 60 will be s divided by s square plus 36, because here a is 6. So if we simplify it, then it will be s square plus 36 minus s square divided by s into s square plus 36. So s square cancel out, and 36 divided by 2 will be 18. So final answer will be 18 divided by s into s square plus 36. Now let us discuss example number 5. Find the Laplace transform of sin cube 2t. So here we know the formula sin 3 theta is given by 3 sin theta minus 4 sin cube theta. Therefore 4 sin cube theta can be written as 3 sin theta minus sin 3 theta. Therefore sin cube theta is written as 1 divided by 4 in bracket 3 sin theta minus sin 3 theta. So here we have to find out sin cube 2t. So we will replace theta by 2t. So it will be 1 divided by 4 in bracket 3 sin 2t minus sin 60. Therefore Laplace of sin cube 2t is given by 1 by 4 in bracket 3 into Laplace of sin 2t minus Laplace of sin 60. Now here Laplace of sin 80 will be a divided by s square plus a square. So it will be 2 divided by s square plus 4, because here a is 2. Same way Laplace of sin 60 will be 6 divided by s square plus 36, because here a is 6. So here 6 is common, so it will be 6 divided by 4 in bracket 1 divided by s square plus 4 minus 1 divided by s square plus 36. So if we simplify it, then it will be s square plus 36 minus s square minus 4 divided by s square plus 4 into s square plus 36. So here s square cancel out, and 36 minus 4 will be 32, and 32 divided by 2 will be 16. 16 into 3 will be 48. So final answer will be 48 divided by s square plus 4 into s square plus 36. Now let us discuss first shifting theorem. So if Laplace of f of t is equal to f of s, then Laplace of e raised to minus at into f of t is equal to f of s plus a. This is the statement of first shifting theorem. Now we will prove first shifting theorem. So we know that Laplace of f of t is given by integration 0 to infinite e raised to minus st ft dt. Therefore Laplace of e raised to minus at into f of t will be integration 0 to infinite e raised to minus st into e raised to minus at f of t dt. So if we simplify it, then it will be e raised to minus in bracket s plus a into t f of t dt. Therefore by definition of Laplace transform, this can be written as f of s plus a. Therefore Laplace of e raised to minus at f of t is equal to f of s plus a. Because f of s is integration 0 to infinite e raised to minus st ft dt. Therefore f of s plus a will be this integration 0 to infinite e raised to minus s plus a into t f of t dt. Similarly, we can prove Laplace of e raised to at into f of t is equal to f of s minus a. Now let us discuss examples of first shifting theorem. First example, find the Laplace transform of e raised to minus 3t in bracket 2 cos phi t minus 3 sin phi t. So first of all, we will find out Laplace transform of 2 cos phi t minus 3 sin phi t. So this can be written as 2 into Laplace of cos phi t minus 3 into Laplace of sin phi t. Now we know the formula of Laplace of cos at. So Laplace of cos at will be s divided by s square plus a square. So by that formula it will be 2s divided by s square plus 25 because here a is phi. Same way Laplace of sin at will be a divided by s square plus a square. So this can be written as 3 into phi divided by s square plus 25 because here a is phi. So if we simplify it, then it will be 2s minus 15 whole divided by s square plus 25. Now by the first shifting theorem, Laplace of e raised to minus 3t in bracket 2 cos phi t minus 3 sin phi t is given by 2 in bracket s plus 3 minus 15 divided by s plus 3 whole square plus 25. So here we have to replace s by s plus 3 because here it is e raised to minus 3t. If it is e raised to 3t, then we will replace s by s minus 3. But here it is e raised to minus 3t, therefore we will replace s by s plus 3. So if we simplify it, then it will be 2s plus 6 minus 15 whole divided by s square plus 6s plus 9 plus 25. So it will be 2s minus 9 whole divided by s square plus 6s plus 34. So this is our final answer. Now let us discuss second example. Find the Laplace transform of t plus 1 whole square into e raised to t. So first of all, we will find out Laplace of t plus 1 whole square. So this can be written as Laplace of t square plus 2t plus 1. So which is equal to Laplace of t square plus 2 into Laplace of t plus Laplace of 1. So Laplace of t square will be 2 factorial divided by s cube because Laplace of t raised to n is n factorial divided by s raised to n plus 1 where n is positive integer. Here n is 2 which is positive integer. So Laplace of t square is 2 factorial divided by s cube. Same way here Laplace of t raised to 1 will be 1 factorial divided by s square. And Laplace of 1 will be 1 divided by s. So Laplace of t plus 1 whole square is equal to 2 divided by s cube plus 2 divided by s square plus 1 divided by s. Now by first shifting theorem, Laplace of t plus 1 whole square into e raised to t is equal to 2 divided by s minus 1 whole cube plus 2 divided by s minus 1 whole square plus 1 divided by s minus 1. Here we have replaced s by s minus 1 because here it is e raised to t. Therefore we have to replace s by s minus 1. So this is our final answer. Now let us discuss third example. Find the Laplace transform of e raised to 2t into sine square t. So first of all we will find out Laplace transform of sine square t. So here we will use half angle formula. So it will be 1 minus cos 2t divided by 2. So this can be written as 1 by 2 in bracket Laplace of 1 minus Laplace of cos 2t. So Laplace of 1 is 1 divided by s, and Laplace of cos at is s divided by s square plus a square. Here a is 2, so it will be s divided by s square plus 4. So if we simplify it, then it will be s square plus 4 minus s square whole divided by s into s square plus 4. So here s square and s square cancel out, and 4 divided by 2 will be 2. So final will be 2 divided by s into s square plus 4. So by first shifting theorem, Laplace of e raised to 2t into sine square t will be 2 divided by s minus 2 in bracket s minus 2 whole square plus 4. Here we will replace s by s minus 2. Okay, so if we simplify it, then it will be 2 divided by s minus 2 in bracket s square minus 4s plus 8. So this is our final answer. Now let us discuss second shifting theorem. So if Laplace of f of t is equal to f of s and g of t is equal to f of t minus a, where t greater than a, and is equal to 0 where t less than a, then Laplace of g of t is equal to e raised to minus as into f of s. This is statement of second shifting theorem. Now we will prove second shifting theorem. So Laplace of f of t is given by integration 0 to infinite e raised to minus st ft dt. Therefore Laplace of gt will be integration 0 to infinite e raised to minus st gt dt. This can be written as integration 0 to a e raised to minus st into 0 dt plus integration a to infinite e raised to minus st into f of t minus a dt. Here g of t is 0 for t less than a. Therefore for this limit it is 0. And g of t is f of t minus a for t greater than a. Therefore for a to infinite it will be f of t minus a. Now suppose t minus a is equal to x. Therefore dt is equal to dx, because derivative of a will be 0, and t will be x plus a. Now when t is equal to a, then x is 0, and when t is infinite, then x is also infinite. Therefore new limits will be from 0 to infinite. So this can be written as integration 0 to infinite e raised to minus s in bracket a plus x f of x dx, because t minus a is x and dt is dx and t is a plus x. Okay, so this can be written as e raised to minus as integration 0 to infinite e raised to minus sx into f of x dx. Okay, so this can be written as e raised to minus as integration 0 to infinite e raised to minus st f of t dt. So integration 0 to infinite e raised to minus st ft dt will be Laplace of f of t, and Laplace of f of t can be written as f of s. So this will be e raised to minus as into f of s. So this is second shifting theorem. Now let us discuss first example. Find the Laplace transform of g of t is equal to sine t minus pi by 4 where t greater than pi by 4 is equal to 0 where t less than pi by 4. So here g of t is equal to sine t minus pi by 4 is equal to f of t minus a. So here f of t is equal to sine t and a is equal to pi by 4. So Laplace of f of t is equal to Laplace of sine t, which is equal to 1 divided by s square plus 1, because Laplace of sine at is equal to a divided by s square plus a square. So here a is 1. So this is our f of s. Now by second shifting theorem, Laplace of g of t is equal to e raised to minus as into f of s, and here a is pi by 4, therefore it will be e raised to minus pi by 4s into 1 divided by s square plus 1, because f of s is 1 divided by s square plus 1. So this is our final answer. So in this lecture we have discussed about linearity, first shifting theorem and second shifting theorem. Thank you for watching this video.